Well, now this is our questions B, okay? That says factorize fully. Again, over here, is this still form 1 of quadratic trinomial? We learned that form 1 was the form x squared plus bx plus c. Specifically, there were no coefficients in front of the x squared in terms of in front of the x squared. Now, are those still quadratic form 1? I mean, this form? You may say no, but the answer is yes. I'll prove it to you. Okay, sometimes questions will appear like this. We are required to transform the equation, okay? If it can be transformed, of course. So no, those questions can be transformed, can be changed. Now, I'll prove it to you. Question 1, for instance. Question 1, we have like 2x squared minus 2x minus 12. So the factor, you notice that this can be, each term here is a multiple of 2, okay? So we can take 2 out as the common factor. So it's going to be like 2, open bracket like that, and close bracket there. Within the bracket, we can write x squared minus x minus 6. Now we retrieve this form of x squared plus bx plus c, or what is in the bracket there. Then we can continue to factorize this. We put x in the brackets, close brackets, open brackets, write x, and then close the bracket there. Then we do as we used to do. We then look at the last term here is -6. Then I can write over here -6. I already know my signs within the brackets here will be positive and negative, or negative and positive. Doesn't matter which one I do first. Okay, the factors of 6 are 1 and 6, 2 and 3. Now the question will be which is there any coefficient in front of the x here? No coefficient? Okay, 0 then. No, it's not 0. Guess what? The coefficient is there, but it is -1. There's 1 there. When you don't see the coefficient in front of the x, just put 1. And then with the sign here, it's -1. Now we're looking for a sum that will be equal to -1 in the list of the factors here. Now let's see which can make -1 there. With 1 and 6, we will never get -1, but with 2 and 3, yes, we can, if it's a +2 and a -3. Now we can say +2 here and then -3 there. Okay, same thing we can do in question 2. In question 2, where we have like 3x squared minus 21x minus 54. Okay, first we look at each term of the expression. Okay, you notice, I guess you notice that they're all multiple of 3. How do I know, for instance? For me, I know like when we to know a multiple of 3 is like when you add all the digits and it gives you also a multiple of 3. Like 3 is a multiple of 3, right? 21, I know this is a multiple of 3 because if I do 21, if I do like 2 plus 1, this is equal to 3. 3 is a multiple of 3. Therefore, 21 is also a multiple of 3. 54, I know 54 is a multiple of 3 because if I do 5 plus 4, this is equal to 9. And then 9, because 9 is a multiple of 3, so will be 54. Then this is applicable only for multiple of 3s, okay? So in this case, I can take 3 as a common factor. So I take 3 as a common factor, and then within the brackets, it will be x squared minus 7x, okay? 54 divided by 3 is equal to 18, okay? Now, we can take x like that in the bracket, and then x in the bracket there, and now we will look at consider the last term, which is -18. I'm gonna write here -18. Okay, and then the factors of 18 are 1 and 18. Okay, 2 and 9, and then 3 and 6. Okay. Now the question says, which couple in the list of the factors of 18 will make a sum equal to -7? Now, we can see that With 1 and 18, we'll never get -7. With 3 and 6, neither. But with 2 and 9, yes, we can get -7 if it is a +2 and a -9. So over here, I'll write +2, and there I'll write -9. Okay? And then this means we can factorize. Now, we will do question 5 then. I will leave question 3 and 4 for you to practice, and then I'm gonna do question 5. Question 5. Over here, we have like x³ plus 2x² minus 8x. Okay. So again, we can see like the coefficients are not, we only have factors between these two terms, but it has to be all the terms. But what else do we have here? We can see that all terms end with highest x's. So we can take x as a common factor. So we can take x as the common factor here, because this is an x³. Okay, it's not a quadratic. X³ is not quadratic, it's a cube. So to make it quadratic, we have to take x out as a common factor. And then this will be x² plus 2x minus 8. Now we have a quadratic trinomial. Now we can do as we usually do. There, x, I'll put x in the bracket there, close brackets. And then I'll consider this -8. So I'll write here -8, factors of -8 are 1 and 8, okay, and 2 and 4. Now, how can I get a sum equal to a +2? You know, it can be +2 only if it's 4 minus 2, right? So it's -2 here and then +4 there. So it's gonna be like -2 and +4 there. I can start by putting +4 and then -2. It doesn't matter, it's still correct. Okay. Now, for question 6, you know what to do. I'm gonna write here question 6. Over here we have like 90 minus 45x plus 5x². So the best way to solve this is like writing this in order, in descending order of exponents, right? So it's better to write it like 5x² minus 45x, to rewrite it like that, plus 90. Then we can factorize as we did. You know, we're going to take 5 as a common factor, and then factorize as we did previously. So thank you. If you really like our videos, please subscribe to the channel, hit the notification bell, and give us a hands up, and then share the link. Thank you.